Greetings and welcome to your geometry recording for the week of January 26th. Just please remember when you go to do your key phrase at the end of this recording, after you take notes and we go through everything, make sure that the key phrase that you complete matches the date of today's or this week's recording. So you should be completing the key phrase assignment of January 26th. So just reminding you that the dates need to match. So please make sure that you have a math notebook out at this time. You do need to take notes as you watch these recordings. It is required that you're taking notes. And the reason is it's going to help you in the long run. A lot of the problems that you see this week are going to look very familiar to the problems that what I'm going to do with you in this recording. So if you have good notes, it's going to help you have something to refer back to guide you as you do this week's assignments. You also are going to be taking the Unit 5 test this week. So having your notes, you can use your notes. You can look at some similar problems that you might see on the test this week. So because we're going to take the Unit 5 test this week, we are going to start with a warm-up problem where we are solving for some unknowns in right triangles. So remember, we've got three different right triangles here. We've got this medium right triangle, this small right triangle, and this overall big right triangle. And in every right triangle, I always like to think of the legs of each right triangle. So let's focus on this right triangle right now so I can explain this. In every right triangle, you've got a short leg, a long leg, and a hypotenuse. And identifying those is really going to help you with setting up your proportions then to solve for your unknowns. So for example, here's our hypotenuse. Remember, your hypotenuse is always directly opposite of that right angle. So sometimes the hypotenuse and long leg get confused, but as long as you're looking at the angle directly across from that right angle, you know it's the hypotenuse. And then this leg down here, it's the long leg, and then this one over here is the short leg. So again, it's very helpful to divide each right triangle up as having a hypotenuse, a long leg, and a short leg. And every right triangle in here has that same pattern. And that's going to help us when we go to set up a proportion to solve for unknown lengths. So in this warm-up, we're solving for B. We need to solve for B. So we need to solve for that hypotenuse right here. So go ahead and click pause now so that you can try this on your own. This is great practice for the Unit 5 test coming up. So go ahead and click pause, try this problem on your own, and then when you're ready to check your work with mine, go ahead and click play. All right, so looking at this problem, we need to solve for B. And it just so happens that I highlighted this triangle that does contain the unknown. So we definitely know we need to use this triangle to help us find B. But we also, if we look at the other triangle that also has B, we could be using the big triangle, this triangle here. It also contains B. And we have another side that is known. So I'm going to go ahead and stick with using the triangle that I have highlighted and think through this. So we know that we have this leg and both the long and short labeled. So we're not quite sure which proportion we want to use yet, which two sides we want to compare. But I definitely know I need to have the hypotenuse labeled in the other triangle that I'm going to use because I need that hypotenuse is definitely going to be part of my proportion that I set up. So looking at this smaller triangle over here, is the hypotenuse labeled with anything? It is not. So we wouldn't want to use this small triangle because we need to have the hypotenuse needs to be labeled in order to use it in our other proportion. So that means I'm going to use the bigger triangle, which I'm going to highlight here. So we're also going to use this bigger triangle to help us find the length of the hypotenuse. So in the other triangle, which legs are labeled? So in the smaller one, we have the hypotenuse, the long, and the short. And in the big triangle, it looks like we have the short leg is not labeled. We have the long leg. So in the big triangle, the short leg's right here. It doesn't have anything labeled. We know that the long leg, and here's our hypotenuse. So that means that the proportion that we're going to use would have to be the comparing the long leg and the hypotenuse. So I always like to write that down so that when I go to write my proportion, I know that those are the two sides that I'm going to compare. I'm going to move that over so that we have enough room for everything. Okay, so let's go ahead and write a proportion. I'm going to start with the small triangle. So in the small triangle, the long leg is 16, and the hypotenuse is b. That's our unknown that we're going to try to solve for. In our big triangle, the green triangle, now the long leg is, which is our long leg? It's this leg right here. It's also b, so I'm going to write that down as b. And then the hypotenuse, which is directly opposite to the right angle, is this leg here, which is split up to 6 and 9. So we need to add those together. So 6 plus 9 gives us 25. So that's going to go here. And now we're just going to solve by cross multiplying. So I would have b squared equals 16 times 25. I'm going to go ahead and 25 times 16, I'm going to multiply that out, and I get 400. And then how do we solve for b when it's being squared? What's the opposite of squaring something? Taking the square root. So whatever I do to one side, I do to the other. So b is going to equal the square root of 400, which is 20. So that would be our final answer. The length of b is going to be 20. So again, splitting those or dividing up that triangle, however you want to think of it, or assigning, I guess that's a better word to use. Assigning each leg as a hypotenuse, short and long, is going to really help you set up those proportions to solve for unknowns when you're working with problems like this. All right, let's move on. This week, we are going to first start out with finishing up Unit 5 with the last concepts that we're going to be learning about, which is the law of sines and the law of cosines. So all along, we've been learning about ways to solve for unknowns in right triangles, where the law of sines and the law of cosines is going to help us solve when we've got non-right triangles. So this last section here, we're kind of getting away from right triangles and looking how we solve for unknown side lengths or unknown angles of non-right triangles. You're also going to do a grade check before you take the test, just so that you are familiar where you're at with your grades and where, if you have any missing assignments, things like that, before you take the Unit 5 test. We'll do a review where we take a step back and look at the big ideas from Unit 5. The Unit 5 project that's going to really help you review everything that we've learned about in Unit 5. And then the Unit 5 test we're going to finish up this week with. So we're going to start with some review this recording for the Unit 5 test. Quick reminders, make sure you're checking your grades. If you turn in late work or redos, you have to message me. And then again, please be patient when you submit late or redo assignments. It does take me a little bit longer to grade redo or late assignments. The best way to get your assignments graded the quickest is to turn them in on time. Some reminders as we're finishing up this unit and as you're taking the test. Make sure your calculators are in degree modes. When you're working with SOHCAHTOA, sine, cosine, tangent, your calculator needs to be in the degree modes to get the correct answers. So if you're using that TI-83 to get your calculator into degrees, let's see here, up in the upper right-hand corner, or near the upper right-hand corner, you're going to see a key on your calculator that says mode. And again, this is if you're using a TI type of calculator. When you click on mode, the third line down, you're going to see radians and degrees, and you just need to highlight the degrees and then click enter and you'll be good to go. One thing that I always remind students is when you're trying to find an angle measurement, so when you're trying to find an angle measurement of a right triangle, if that's an unknown, and you set up SOHCAHTOA, you always need to use the inverse to solve for that. And we have an example that we'll go over today. So let's look here. Let's look at number 2 because that's an example. So in number 2, our unknown is a degree or is an angle measurement. Our unknown is an angle measurement, which tells us when we go to finally solve, we need to use the inverse of sine, cosine, or tangent. So let's look here. So we need to find this angle measurement. So that means this is our reference point. So what two sides are we given in relation to that angle measurement? Are we giving the opposite, the hypotenuse, the adjacent? Which two sides are we given to set up to figure out if we're going to use sine, cosine, or tangent? Well, we're given the side opposite. This leg over here is the side opposite. This leg here is the hypotenuse. Remember, adjacent can never be the hypotenuse. So when we talk about the adjacent side, that would be this side here. Even though this is technically adjacent, it's more specifically the hypotenuse. All right, so we've got the opposite side and the hypotenuse that are given. So does that mean we're going to use sine, so the cosine, or the tangent? Which one are we going to use? Well, since we're given the opposite and the hypotenuse, that means we're going to use the sine. So let's set up that proportion. We're going to have sine. Whatever the degree measurement of the angle is goes right after sine. That's usually where we put that's always where we put the angle measurement. Since we don't have that, we're going to leave that as x. That's our unknown. Set it equal to the opposite over the hypotenuse. So this is where you want to use the inverse. So in order to find a missing angle, you must use the inverse of sine. And when we use that on our calculator, it's going to look like this. The inverse is where you've got that -1 next to it, sine raised to the -1. You're going to use that on your calculator, and then you're going to type in 8/13, and that's going to give us our answer. So go ahead on your calculator. You're going to have to hit that second key if you're using a TI, a Texas Instrument calculator. Hit the second key and then that sign, and that's going to give you that inverse sine, and then type in 8 divided by 13. And when I did that, I got 37. I'm going to go to 2 decimal places, 98, and that's my final answer, degrees. So that's my final answer right there. So again, because I'm trying to find an angle measurement here, and the angle always goes right after the sine or the cosine or the tangent, then you need to use that inverse key to find that missing degree. All right, let's look at that first question. Here's another good review of using trig ratios to solve. So remember, anytime we have a right triangle, and we have we have 3 things given, any 3 pieces of a right triangle, whether it be side lengths, angle measurements, or we're trying to find an angle measurement. Anytime you have 3, well, actually, I guess 2 givens and 1 unknown, 2 givens and 1 unknown, you're going to use one of our trig ratios. Again, we can only use trig ratios when we have a right triangle. So if you're given 2 pieces and you need to find a third, you can use one of our trig ratios, that SOHCAHTOA, or that sine, cosine, tangent. So let's look at this one. This one, we have 1 angle measurement, so we can use that as our reference. What 2 sides are we given in reference to that angle measurement? We have the adjacent and we have the opposite. So what are we going to use? So, ka, or toa? Opposite and adjacent means we're going to use tangent, the toa. All right, so let's set up our our proportion here. We're going to have tangent. The degree always goes right next to the tangent, equals opposite over adjacent. All right. So a lot of students get mixed up here when our unknown is in the denominator. So we need to get the unknown, that x, not to be in the denominator. So what I'm going to do is I'm going to multiply both sides by x. That way I get that the x's cancel out over here. And now we're left with this equation. X times tangent 51 equals 46. How do I get x alone? X is being multiplied by tangent 51. That's right, you divide each side by tangent 51. So what we're doing here now is we're typing in our calculators 46 divided by tangent 51. So you'll type in your calculator 46 divided by tangent 51. And on our right side, the tangents cancel out and we're left with just what x equals. X equals, what is 46 divided by tangent 51? You should get 37.25. So again, if you're not getting these answers, make sure you're in the correct mode, that you're in degrees and not radians. So that's a good review of using trig ratios to solve for unknowns in right triangles. So again, we use trig ratios when we're given two pieces of a right triangle and we need to find a third, an unknown. All right. So again, just a reminder that when you're trying to find an angle measurement, you need to use the inverse. So angle measurements mean we have to use the inverse. So here, you've got an equation where it says sine x equals 0.5. So this is, our x is representing an angle measurement, because remember the angle always goes right after sine, cosine, or tangent. So to solve for this, what we're going to do is we're going to type into our calculator the inverse of sine times 0.5. So you're going to hit second sine and type in 0.5, and you'll get your answer. Go ahead and type that in, and you should get 30 degrees. So go ahead and try that in your calculators. Make sure you know how to do this so that when you go to take the test this week, you're good to go. I'm going to go on to the next slide. Some quick review on 30, 60, 90 triangle patterns. This will also be on the unit test. So let's review. So up here in the corner is the patterns that we get. Over here is the patterns that we get. Make sure that when you are looking at your problem that you know which angle or which side lengths are given between what two angle measurements so that you're good to go there. So here we are given the hypotenuse. That's an easy one because it's directly across from the right angle. That's given. We need to find A and B. So this angle measurement isn't included, but we know what it is, right? It has to be 30 degrees because we know the other angle is 60 and the other one is 90. So that means that angle that wasn't included is 30 degrees. All right, so the easiest way to solve 30, 60, 90 triangles is to first identify what the x value is. So we know that the hypotenuse is represented by 2x. We know that our hypotenuse that we're given is 40. So now we can solve for x just by dividing each side by 2. X would equal 20. Once we know what x is, we can go back to the patterns and just plug that in, right? So between 60 and 90, the value should just be plain old x. Well, we know x is 20. So between 60 and 90, this one's oriented in a little differently, so that's okay. That's why I said you got to really pay attention to where the degree measurements are and the lengths of the triangle. So here's our 60, 90, so that should be just x. We know x is 20, so that means that b, this side length over here, should be equal to 20. We now are looking at this measurement here, a, which is between 30 and 90. Between 30 and 90, the length should be x radical 3. Well, we know x is 20 times radical 3. That's what a equals. And we're done. So again, the easiest way to do these types of problems is look what you're given. Which value are you given? What length of the triangle? Set it equal to whatever the pattern is and solve for x. Once you have x, you can go around and plug it right in. It's a lot easier that way. I'm going to move on now, so if you need to take notes, click pause. All right. Law of cosines and sines is the last concept that we are learning in this unit. So far, every method that we've learned about Pythagorean theorem, special right triangles, meaning 30, 60, 90 triangles, 45, 45, 90 triangles, trig ratios, sine, cosine, tangent, those trig ratios, all of those we used to solve for missing side lengths or angles in right triangles. Well, now we're given a method to use if we don't have a right triangle, a non-right triangle. So we use the law of cosines or the law of sines when we're dealing with solving for unknown side lengths or unknown angles in non-right triangles. This is when we use the law of cosines or the law of sines, when we're looking to solve for unknown lengths or unknown angles in non-right triangles. All right, so let's start with the law of sines. Law of sines. When do we use the law of sines? And hang in with me, we'll eventually get to what it is. But first we want to know, when do we use it? We use it when we know two sides, when two side lengths are given and one angle is given. So here is an example. If you were given a triangle where we have two known sides and an angle, then we can use the law of sines. The other case is when you have two angles and one side. So here, if you have two angles and one side, you can use the law of sines. So it's important that we know the difference between using the law of sines and cosines and when to use each. So write this down. Write this down. When you have either two known sides and one unknown angle, or two known angles and one known side, then you can use the law of sines. So you have to always have an angle and a side that are opposite of each other too, of your knowns. The angle and a side, you have to have one pair that is opposite of each other. That's when you use the law of cosines. So what is the law of cosines? It's when we're setting up a proportion. When we're setting up a proportion, the proportion is going to be a side length A over the sine of the angle A. So that angle opposite to that side, you would say side A over, you're going to say sine of that angle measurement. And you're going to set it equal to, when you have side B, over, remember the side directly opposite of it, sine of that angle. And then you can also do it for that third side. You only need to use two. You only need to use two. You're not going to have three equal signs. You're only going to use two ratios because of proportion, you only have one equal sign. So you can use any of these two together. You can use any of these two together. You can say A is equal to the C1. You'll see what I mean in here. So let's look at an example. So here we've got two known sides and an angle. So I know that I'm going to use the law of sines because I have two known sides and an angle. So I'm going to use the law of sines. What is the unknown here? It's this angle. We want to figure out what that angle is. So let's go ahead and set up a proportion. So the proportion says if you have a known side, put that over the sine of the angle opposite of it. So sine 115. Equals, well, what are we trying to solve? This angle that's opposite this known side. So we would say 16 over sine of x. So we're going to use cross multiplication to solve. We're going to use cross multiplication to solve here, just like we do with every proportion that we set up. So what do we have? We've got 49 times sine x equals 16 times sine 115. So I'm going to look at the right side of this equation and I'm going to type all that out. I'm going to get rid of all that. I'm going to type it in my calculator and simplify, not get rid of it, simplify it. So I'm going to type in 16 times sine 115. And when I type that in my calculator, 16 times sine 115, I get 14.5. So we still have this 49 times sine x on the left. So we want to work on getting x alone, so I'm going to get rid of that 49. It's being multiplied by sine x, so I'm going to divide it on each side. So now I've got sine x equals this, divided by 49. So how do I solve from here? So remember, we're trying to find an angle measurement. Anytime we're trying to find an angle measurement, we have to use the inverse of sine. We have to use the inverse of sine. So what I'm going to type into my calculator is I'm going to type in, running out of room here, I'm going to type in sine to the -1, and then I'm going to put 14.5 over 49. That's how I'm going to solve for that unknown angle, for x. So I'm going to type in my calculator, the inverse of sine, 14.5 divided by 49. And when I do that, I get 17.2. 17.2 degrees. That's my final answer. That's my final answer. So here we use the law of sines to set up a proportion. So note, we didn't use all three. When I set up my proportion, I didn't use all three of these. You only use two. You only are going to ever, when you have a proportion of one equal sign. So you only need to use 2 out of the 3, depending on what you're given. I'm going to keep going. So if you need more time to write down notes, please click pause now. I want to go on and get law of cosines. We're running out of time here. So law of cosines. When do we use law of cosines? We know we use law of sines when we have two side lengths and a known angle, or two known angles and an unknown side. Where cosines we use when we know two sides of a triangle and the included angle. So the angle has to be sandwiched between two known sides. So we would need to, like for example, if we had this was known, and this was known. That's an example of two known sides and the included angle. Then if we were given these, so let's say like this side was 20, this side was 16, and this angle was 30 degrees, we could use the law of cosines. So the law of cosines is a little long of a formula. You're going to use, so in this example, c squared equals a squared plus b squared minus 2ab cosine c. So let's see an example here. It'll make more sense. It's always good to have a nice example. All right, how long is side C? We're trying to find the opposite side of that angle that's given. That's how it's always going to work when you're trying to use the law of cosines. Note we have the two angles that are given and the included angle. Thus we use the law of cosines. And we're trying to find this side length here, x, which is located directly opposite of the given angle. So we're going to use the law of cosines. The law of cosines says side c squared equals a squared plus b squared minus 2ab times cosine c. Let's plug everything in there. And remember, you'll have good practice and even more lessons to go over this week. C squared, we don't know that side length, so I'm going to keep that as c squared plus a squared. So a squared would be 11 squared plus the other given side, which would be 8 squared, minus 2 times AB. So AB is always going to give those be the two sides that are given. And then cosine C, and that's 37 degrees. C squared. Oh, I forgot the equal. I was like, so what is going on there? There's that equals, not plus. That should have been equal. There we go. So let's go ahead and simplify the right side of the equation. 11 squared is 121. I know 8 squared is 64. I'm going to take away, what's 2 times 11 is 22. 22 times 8 is 167, cosine 37. So I'm just going to do a little bit at a time here. So remember, order of operations tells us we need to multiply. So let's go ahead and multiply 176 times cosine 37. So I'm looking at the end of that equation there. I'm going to do my multiply all of this right here. So I've got 121 plus 64 minus 140. When I multiply that in my calculator, 176 times cosine 37, I get 140. I'm going to go to 2 decimal places, 0.56. And then order of operations, we're going to add and subtract as we move from left to right. So 121 plus 64 gives us 185, and subtract 140.60 from that, and we get 44.44. So remember, this was always equal to c squared. So we're not done yet, because that was equal to c squared. We want to get c all alone, so we're going to take the square root of both sides. So the square root of 44.44, and I get an answer of c equals 6.67. And we're done. So that is the law of cosines. That is the law of cosines. This side here was side A. This was side B because it's directly, this would be, side A because it's directly opposite of angle A. This side over here would be side B because it's directly opposite of side B. That's the law of cosines. So you're going to have more practice. I know you probably don't feel like you completely have the law of cosines down just yet, but remember, that's what this week's lessons are for. There's lots of slides, lots of videos, and practice problems for you to practice and get better with that. So you're ready for the key phrase assignment. Remember, we're doing the week of 126 key phrase assignment. You need to answer this question. So what do you use when trying to figure out an unknown, it could mean angle measurement or an unknown side. I just put angle measurement, but it could also include an unknown side of non-right triangles. So what 2 things did we learn that will help us solve for unknown angle measurements or unknown side lengths of a non-right triangle? So far in Unit 5, we've been focusing on right triangles up until this last session. So what do we use to help us find missing unknowns in non-right triangles? Remember, if you need a review of how to complete the key phrase assignment, it's right here, so you can read through that. And that's the end of this week's recording. So I'm going to stop the recording. Be sure to let me know if you have any questions as you're working throughout this week. Have a great rest of your week.